Missioning to encourage the substantial use and reducing upstream will reduce from the upstream cell from the upstreams and reduce the sediment production sediment trapping above the reservoir and reduce the sediment production sediment trapping from above the reservoir reduce sediment erosion sediment trapping and above the reservoir कहीं पढ़ा है ना मैंने sediment trapping initial stage and sediment trapping occurs continuously during the flood event. Sediment accumulates starting from the deepest part of the reservoir, eventually forming the flat sediment deposits and partial sediment. The reservoir transitions from the mixed regimes of deposits and removal, and sediment continues, and reservoir capacity to store the sediment diminishes, leading to the development of the floodplain change and the changes floodplain and configurations and sediment continues, the reservoir capacity to store the sediment diminishes and the leading to development of the channel floodplain configuration. The inflow and the discharge of the fine sediments become balanced. Of course, bed continues to and the inflow and outflow of the inflow and the discharge of the fine sediments become balanced and discharge of the fine sediments become balanced. Core sediments being sent to accumulate sediment management techniques such as drawdown periodic flushings are employed to achieve the partial sediment balance and the drawdown or periodic flushing are employed to achieve the partial sediment balance and the preserve the reservoir capacity. To prevent the partial sediment balance and preserve the reservoir capacity, full sediment balance and a long-term balance between sediment inflow and the outflow is achieved. Full sediment balance, long-term balance between the sediment inflow and outflow is achieved. The final course sediment portions are effectively managed either by any the fan and the core Sanigere sediment portions are effectively managed, and in the fan and core sediment are effectively managed either by the transporting them beyond the dam or through the artificial removal method. And fan and core sediment portions are unif and the fourth fan and core sediment portions are effectively managed either by the transporting them beyond the dam or through the artificial removal method. However, sediment movement through the any reservoir may differ from the pre-impound conditions as the sediment accumulations and removal occur intermittently during the smaller event or through dredging and flushings and achieving full and sediment balance require the substantial management practices. And the long-term balance between the negative sediment inflow and the sediment outflow is a sediment inflow and outflow is achieved of long-term balance and negative fine and core sediments and portions are effectively managed either by fine and core sediments are effectively managed either by transporting them beyond the dam through or through the artificial removal method. There's something. Sediment fund outflow of the achieved on final course sediments are any final course sediment deposits are effectively managed either by transporting them beyond the dam or through the artificial removal method. And final course sediments are any the final course sediment portions are final course sediment portions are effectively managed. The finance and course sediments portions are final course sediments are managed either by through transporting them beyond the dam or through the artificial removal method. Either the final course sediment transports are the final course sediment portions are effectively managed by the transporting them beyond the dam. Finance cost sediment portions are effectively managed and either by transferring them beyond the dam or through the artificial removal. Finance cost sediments are managed through and transferring them beyond the dam or through artificial removal method. Our sediment movement through the reservoir were differ from the pre-impounded condition as sediment accumulation and removal occur intermittently during the smaller event or through dredging and flushing. Achieving the full sediment balance requires a substantial can there is an the removal can either through the transporting beyond the dam or the downstream of the dam or through artificial removal method. And like to get started, allow our sediment management through the reservoir by differ from the pre-impounding conditions. Sediment accumulation removal both occur intermittent long-term balance and get a final question is that one is importance of reserve sediment management and renewable versus the exhaustible sources and importance and renewable versus exhaustible source while hydropower is often touted as renewable energy source. The renewable exhaustible nature of the storage projects being on design and operations when an reservoir becomes filled with sediments, they may no longer be economically feasible to use, leading to their exhaustion as the resources and design of philosophy and design life philosophy. The investment cost, the conventional storage project require the historically have historically been past to other infrastructure, civil infrastructure like the building and bridge, the approach assume that the investment cost will be recovered throughout the project life, benefit over the design life. The investment cost will be achieved and recovered throughout the project, benefits over the design life with little considerations for the consequences beyond the period. And investment cost will be recovered through the project and get benefits over the design. Investment cost will be recovered through the project benefits and design life with a little consideration and consequence beyond this period and exhaustions and design life or a life cycle management approach and we go throughout the project benefit or design life which will consider consume and beyond the period and this is the extension of the reservoir as sediment accumulates in the reservoir over time it can lead to the decreased storage capacity reduce efficiency of the hydropower plant generations and as the sediment accumulates in the reservoir over time leads to the decreased storage capacity reduce the efficiency of the hydropower generation so become reservoir becomes unfilled with the sediment the cost of the sediment removal become probably high rendering them unsuitable and exhausted as the resources the design paradigm has shifted toward the life cycle management approaches and while the hydropower and is often touted as the renewable energy source, the renewable or exhaustible sun nature of the storage project depend on its design and operations and hydropower often touted as renewable energy source, the renewable or exhaustible nature of the project depend upon the renewable or exhaustible nature of the storage project depend on its design and operations. When the reservoir and becomes filled with the sediments and renewable or exhaustible nature of the storage project depend on its design and operation and the renewable or the exhaustible nature of the storage project depend on its design and operation. The renewable or the exhaustible nature of the storage and the renewable or exhaustible nature of the storage project depend on its design and operations. When any reservoir becomes filled with sediments, they may no longer become economically feasible to leads to their exhaustion as the resources. And then reservoir becomes filled with sediment. Reservoir becomes filled with sediments and here they may no become when the reservoir becomes filled with sediments and they may become no longer economically feasible to use leading to the exhausting as the resources and so sediment accumulates with the reservoir over time and storage capacity reduces and eventually as a life cycle management process and concept of disposal and emphasize sustainable use of the reservoir almost involves implementing sediments management strategies and the regular refurbishment of the dam to extend their lives. Adopting life cycle management approach entails the embracing circular approach of the reservoir management. adopting a life cycle and care management and entails embracing a circular approach to reservoir management and which involves implementing sustainable practice for sediment management, that is sediment trapping and removal efficient techniques, and which involves the implementing sustainable practice. Adopting life cycle management approach entails providing circular approach to the reservoir management, entails approaching the circular approach to this reservoir management and entails embracing a circular approach to reservoir management, which involves implementing the sustainable practice and implementing sustainable practice to sediment management and circular life cycle management, also implement the circular life and implementing the sustainable practice for the involve sustainable implementing sustainable practice to the management, the sediment trapping and the removal techniques, and consider how the societal and the environmental throughout the life cycle of the projects, and consider the societal and environmental throughout the life of the project's residual concerns, that is decommissioning to encourage the sustainable use, and consideration of the societal and environmental throughout the life of the projects, and eliminating the threat of losing any reservoir ability to store the water over a very long time, promote the continued use of the damaged or providing utilizing of the both resource such generations, and considerations of the societal and environmental and concerns and which occur throughout the environmental concerns and which occur throughout the life of the project, residual concerns and such as decommissioning to the encourage taken into throughout the life cycle of decommissioning are taken into account throughout the life of the project, which encourage sustainable use including through sediment management and reservoir and sediment management and reduce upstream spills, route and sediments, remove or reduce distributes the reducing upstream sediment management strategy to reservoir sediment management strategy, and I think sediment management taraftarı sayısı yani. Hydropower projects, RR, PRR आणि sediment management आणि strategy in management strategy in the reservoir and reduce the upstream yield and reduce the upstream yield and reduce the sediment production, sediment deliver trapping above the reservoir, and sediment and reduce the sediment productions, reduce the upstream yield route the sediment, reduce the upstream yield route sediment, reduce the upstream yield route of the sediments and reduce upstream yield route sediments, remove or redistribute the sediment deposits and reduce or remove or reduce the redistribute the sediment deposits, remove or redistribute the sediment deposits, and adaptive strategies and remove or reduce the remove or redistribute the adaptive strategy, remove or redistribute the adaptive strategy, remove or redistribute the adaptive sediment, remove or redistribute the sediment deposits and adaptive strategies, and reduce the upstream yield from the upstreams, reduce the sediment inflow from the reduce sediment inflow from the upstreams, reduce the sediment inflow from the upstreams, routing sediments and maintain transport, minimize depositions and reduce the sediment inflow from the upstreams, route the sediments and remove Reduce, remove, resist, remove and redistribute the sediment deposits, remove or redistribute the sediment deposits, adaptive strategy. Reduce the upstreams, reduce the sediment inflow from the upstreams and yield and reduce the sediment inflow from the upstream, reduce the sediment inflow from the upstream, reduce the sediment inflow from the upstream, reduce the sediment inflow from the upstreams, yield route the sediments and remove or redistribute the sediment deposits and route sediments, remove or redistribute the sediment yield and sediment deposits, adaptive strategies and Mm, reduce and sediment and you reduce the sediment productions and sediment trapping above the reservoir and you reduce the sediment trapping above the reservoir and sediment trap above the reservoir नेहाला सायद provide large dam अनि के अरे disperse the structures and width बढाउने होइन त्यो check dam अनि farm ponds above the upstreams. Reduce the sediment inflow from the upstreams, reduce sediment inflow from the upstreams अनि के अरे reduce the sediment routes in sediments and reduce the sediment inflow from the upstream route sediments, remove or redistribute the sediment deposits and remove or redistribute the sediment deposit, adaptive strategies and reduce the sediment inflow from the upstreams and reduce sediment inflow from the upstreams, reduce the sediment productions र अनि sediment trapping above the reservoir, sediment trap above the reservoir and reduce sediment अनि productions, reduce sediment productions मा फेरि अनि के अरे reduce sediment production कसरी reduce गर्ने, soil erosions control, revegetations and channel erosion control. Reduce the sediment erosions and through the soil erosion control or अनि के अरे revegetations and soil erosion control, revegetations र channel control erosions अनि channel erosion control, soil and erosion control or revegetation, soil erosion control or revegetation, channel erosion control and soil erosion vegetation अथवा अनि control or revegetation मा forest, rangeland, farms, constructions अनि के अरे sites and developed area, farm, rangeland अनि forest, rangeland, farms यो soil erosion control and the revegetations अनि अर्को चाहिँ channel erosion control अनि soil erosion control, channel erosion control, soil र channel erosion control, revegetations अनि channel erosion control चाहिँ gully stabilization, stream channels stabilizations, gully stabilizations, stream channel stabilizations र restorations. Gully stabilizations, stream channel stabilizations and restorations, gully stabilizations, stream channel stabilizations and restorations, stream channel stabilizations and restorations, reduce the sediments productions and reduce sediments productions अनि अर्को चाहिँ sediment trapping above reservoir अनि reduce sediment productions मा पनि फेरि के छ हाम्रो अनि soil erosion control or revegetations अनि यहाँ चाहिँ channel erosion control and soil erosion कस्तो याद नभए channel erosion control अनि reduce sediment and get productions and sediment trap above the reservoir, sediment trap above the reservoir and sediment trapping above the reservoir, reduce the sediment productions and reduce the sediment inflow from the upstream, reduce the sediment inflow from the upstream and reduce the sediment productions and soil control erosion, channel control erosion, soil control erosion, channel control erosion, soil control erosion, channel control erosion, soil control erosion मा चाहिँ अनि soil control erosion अनि के अरे forest and अनि farms, rangeland, forest farms अनि soil control erosion and soil control erosion, forest farms, rangeland, construction sites and developed areas, construction site and developed areas, forest farms, rangeland, construction site and developed area. अनि channel erosion control मा चाहिँ channel bed stabilizations, gully stabilizations, channel bed and stream channel stabilizations and restorations. Forest farms and rangelands and construction site and developed area, forest farms, rangeland, construction site and developed areas and route sediments and maintain transport, minimize the depositions and cause large dam disperse structures and check dams or farm ponds and nuclear reduce sediment from the upstreams and um, route sediments and this was maintain transfer minimize depositions, maintain the transfer minimize depositions, route sediments and sediment bypass and route sediments में sediment bypass sediment pass through sediment bypass sediment pass routing sediments maintain transfer minimize depositions and sediment bypass sediment pass through sediment bypass में फ्लड बाइपास च्यानल अनि के अरे बाइपास टनल सेडिमेन्ट बाइपासमा फ्लड बाइपास च्यानल अनि के अरे बाइपास टनल र अपस्ट्रिम्स रिजर्भर अनि बाइपास टनल्स फ्लड बाइपास च्यानल्स अनि सेडिमेन्ट बाइपासमा नि फ्लड बाइपास च्यानल अनि त्यसपछि बाइपास टनल अनि अपस्ट्रिम्स रिजर्भर बाइपास टनल्समा चाहिँ अनि हाई बाइपास र लो लेभल बाइपास अनि ड्रडाउन सेडिमेन्ट पास थ्रु अनि के अरे रिजर्भर ड्रडाउन एन्ड स्लुइसिङ्स अनि के अरे भेन्ट अरबिट डेन्सिटी करेन्ट फेरि मोनिटरिङ है त अनि के अरे एउटा चाहिँ बाइपास सेडिमेन्ट बाइपास र सेडिमेन्ट अनि पास थ्रुमा फ्लसिङ एन्ड अनि के अरे रिजर्भर ड्रडाउन एन्ड स्लुइसिङ्स रिजर्भर ड्रडाउन एन्ड स्लुइसिङ्स अनि भेन्ट अरबिट डिस्चार्ज अनि करेन्ट reduce the upstream inflow from the reduce the sediment erosions र अनि के अरे sediment productions reduce the sediment productions अनि अर्को चाहिँ sediment trapping above the reservoir reduce sediment productions मा अनि के अरे soil erosion control and अनि vegetation channel erosion control forest range and farm construction site and developed area gully stabilization strength channels अनि के अरे stabilizations and restorations अनि remove or redistributes अनि sediment deposits mechanical removal modifying operating rules अनि hydraulic scouring and remove or redistribute the sediment deposits mechanical removal and remove or redistributes the sediment deposits remove or redistributes and reduce and get is upper sediment inflow from the upper streams and sediment routing route sediments and remove or resist redistribute the sediment deposits either through the mechanical removal modifying the operating rule or hydraulic scouring and mechanical removal modifying the operating rules or hydraulic scourings and mechanical and remove or redistribute the sediment deposits remove the sediment deposits either through the mechanical removal and modifying operating rules र अनि के अरे hydraulic scars mechanical removal dry excavating अनि के अरे dredging गरिन्छ dry dredging mechanical removal or dry excavations or dredging can be done through the hydraulic suction dredge and airlift dredges and hydraulic suction dredges and airlift dredges mechanical lift agitations dredge and mechanical lifts agitations dredge and hydraulic dredge and hydraulic suctions dredge and airlift dredge mechanical lift र air suctions agitations dredge and अनि अर्को चाहिँ modifying the operations rule र hydraulic scouring अनि pressure flushings र empty flushings and sediment pass through sediment bypass and reduce the sediment productions and trap the sediments above the reservoir and so then the valley and flood bypass channels and get bypass tunnels flood bypass tunnels र अनि upstreams reservoir अनि flood bypass channels and get flood bypass channels अनि tunnel र upstreams reservoir flood bypass channels bypass tunnels र upstreams reservoir drawdown and sluicing vent turbid and density current and adaptive strategies and reallocate the storage, improve the operational efficiencies, and reallocate storage and improve the operational efficiency, modify intakes and hydro turbine to handle the sediments, rise dam to increase the volume, rise the dam to increase the volume, and water loss control and the conservation's decommissioning of the infrastructures and adaptive strategy. Uh, reallocate the storage and adaptive management strategy and reallocate storage and improve the operations and storage reallocate गर्ने फेरि improve the operational efficiency modifying intake hydro turbine to handle the sediment reallocate the intake अनि के अरे storage and the improve hydraulic efficiency अनि improving the modifying the intakes hydro turbine to handle the sediment modifying the intake hydro turbine to handle the sediments and rise the dam to increase the volume management strategy rise the dam to increase volume water loss conservation and control decommissioning infrastructures के छ भन्दाखेरि सुरुमा reallocate the storage, improve the operational efficiency, and modify the intake hydro turbine to handle the sediment. Modify intake hydro turbine and इन्टेक हाइट अराउन्ड मेसिनहरू मोडिफाई गर्ने अनि स्टोरेजको रिएलोकेट गर्ने हाइट ड्याम इन्क्रिज गर्ने वाटर लस कन्जर्भेसन एन्ड कन्ट्रोल एन्ड कन्जर्भेसन्समा इस्टाब्लिस गर्ने अनि डिकमिसनिङ अफ द इन्फ्रास्ट्रक्चर यदि भएन भने चाहिँ नि source of sediment encashment skills control अनि इरोजन कन्ट्रोल यो सोइल इरोजन कन्ट्रोल च्यानल इरोजन्स अनि कन्ट्रोल क्याचमेन्ट स्किल्स इरोजन कन्ट्रोल स्मल चेक ड्याम्स प्रोभाइड अनि के अरे रिड्युस द लार्ज डेब्रिज ड्याम अपस्ट्रिम्स and dam or other structures and and get a catchment skills and erosion control and can erosion control and to address the root cause of the sedimentations by preventing soil erosion from occurring in the first place. And Mm, it's not good. So prevent the root cause of the sedimentation by preventing soil erosion from the occurring at first place. Catchment scale erosion control. Um, I don't know. Address the root cause of the sedimentation by preventing soil erosion from occurring in the first place. The Casminson is scales erosion control to address the erosion and root cause of the sedimentation and to determine the root cause of the sedimentation and by preventing the soil erosion from occurring in the first place, determine the root cause of the cause and effects. Just to say, and Casmin scale soil erosion and erosion control and methods vegetations cover. Control plowing and terracing. Vegetation cover and control plowing and terracing and shows the runoff and down runoff, slow down runoff and minimize the soil erosion due to the moisture and minimize slow down the moisture and slow down slow down runoff, minimize the soil erosion and retain the moisture and vegetation have degraded area. Restoring vegetation in the area that have been degraded by the activities as well. Ah, revegetation of degraded area. Deforestation or mining and helps to prevent this much. So, revegetation deforested area from mining area man, which helps to prevent the soil erosion and promote the soil stabilizations and slow down the runoff, minimize the soil erosion and retain the moisture and control plowing and terracing and catchments, skills erosion control, reduce sediment productions and get a soil erosion control, revegetation channel erosion control and sediment trapping above the reservoir and similarly. Uh, Small check dams and get a large debris dams, stop streams dams for the other powers. Small check dams constructed along the uh, stream channels at the upstream of the reservoirs to intercept and temporarily store the sediment layer and water and runoff. Regular maintenance essentials to prevent the sediment. So the regular maintenance isn't necessary for essentials. Prevent the sediment build up behind the dam so it does not ensure their continued effectiveness in trapping sediments and large debris damage. Trap sediment as well as wooden debris. Trap the sediment as well as wooden debris carried by the upstream sun runoff requires significant initial investment for the construction and ongoing maintenance. And um, yeah, trap the sediment as well as woody debris carried at the upstreams of the runoff and require the significant initials. I require significant IEE for construction and ongoing maintenance. And uh, hi, madam. Um, 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 strategy to reduce the sediment yield from the upstream area नि upstream area मा चाहिँ reduce the sediment productions अनि के अरे र sediment trapping above the reservoirs अनि यो नि चेन्ज हुन त routing sediments and remover redistribute the sediment depositors and mechanical remover and dry excavations and dredging and hydraulic dredging hydrosuctions dredging and airlift dredges mechanical lifts and air agitations dredges and hydraulic scarves and modifying the operations rules hydraulic scarves pressure the empty flushings and reallocate the storage and improve the operational efficiency modify the intake hydroturbine to handle the sediment modify the intake hydroturbine to improve the handle sediments raise the dam to increase the volume and get water loss conservations control and the conservations decommissioning and water loss conservations and control water loss control and conservations and water loss control and the conservation decommissioning of the infrastructures and source of sediment catchment surface erosion seed erosions and hill slopes mass movement and landslide rockfall debris flow mud flow and in-stream erosion, rills and gully erosions, and surface erosion, seat erosions, and in-stream erosions, bank or bed, and rills and gully erosion. Hill slopes are the slope is mass movement, and hill slopes are mass movement, and in-stream erosion, and bed and bank, rills and gully erosion, hill slopes are mass movement, and landslide, rockfall, debris flow, mudflow, landslides, rockfall, debris flow, mudflow, reduce and get upstreams and inflow from the sediment inflow from the upstream with catchment skills and sediment management catchment skills sediment management and Piedmont and intermediate high small shake and ground diameters of the fan and uh, protections of the soil against surface against the direct in raindrop impact is important in reductions of the erosion rate vegetation is the most important factor in controlling the erosion and retaining sediment in channel and stabilizing channel selective check dams and selected check dams reduce the sediment transported and uh, increase the sediment deposits behind any selected and get check dams and reduce the sediment transport capacity of the streams and increase the sediment transports behind and reservoir sediment management and these are adapted in operations part of the reservoir, typically not controlled by the project's owner. Catchment skills, erosions control, and costly enemy involves and many thousands of the land users. Slow and the uncertain implementations and downstream response is usually slow. Small check dam available capacity and subjected to the eventual failure releasing stored sediments but can be effective if the installs in large number and well maintained. Large debris dams are costly and need regular clearance and the maintenance of the preparations for the next events and upstream dams built for the hydrogen. Mm, fucking routing and sediment bypass tunnel bypass and sediment bypass sediment pass through मा अनि के अरे रिजर्भर ड्रडाउन एन्ड स्लुइसिङ्स र भेन्ट अनि टर्बिड रिलिजिङ टर्बिड करेन्ट अनि सेडमेन्ट पास थ्रु सेडमेन्ट बाइपासमा अनि के अरे फ्लड बाइपास च्यानल्स अनि के अरे बाइपास टनल्स र अपस्ट्रिम्स रिजर्भर सेडमेन्ट बाइपास अनि सेडमेन्ट बाइपास र सेडमेन्ट पास थ्रु अनि सेडमेन्ट बाइपास फ्लड बाइपास च्यानल्स अनि फ्लड बाइपास च्यानल अनि बाइपास टनल अनि सेडमेन्ट बाइपास फ्लड बाइपास च्यानल अनि बाइपास टनल अनि अपस्ट्रिम्स रिजर्भर सेगमेन्ट बाइपास फ्लड बाइपास अनि च्यानल फ्लड बाइपास टनल अनि के अरे बाइपास टनल फ्लड बाइपास च्यानल्स टनल बाइपास अनि र सेडिमेन्ट अनि अपस्ट्रिम्स रिजर्भर अनि Sediment pass through reservoir and drawdown and sluicing reservoir drawdown and sluicing run releasing turbidity current and sediment bypass sediment pass through flood bypass channels and tunnel bypass र reservoir upstream reservoir and highly effective method of the choice where the feasible and dramatically reduce or drawdown and reservoir level is reduced during the flood and allowing maximum flow velocity through the reservoir and minimizing sedimentation. Some sediment may be is carved and get brought in bypass and get sediment bypass and routing and get sediment bypass diverting sediments laden water away from the reservoir through the upstream storage or bypass tunnels and there is a diverting the sediment laden water and away from the main channels to the downstreams of the and get structures through the upstream storage or upstream storage or through the upstream storage or any sediment bypass tunnels and upstream storage and bypass from the upstream cirrhosis discharge of flood area and design discharge होता गयो यहाँ चाहिँ QF minus QD हुन्छ अनि discharge अनि के अरे bypass on storage of on stream storage bypass on stream storage and sediment bypass systems require the significant and infrastructures investments but offer any long-term benefit by preserving the reservoir storage capacity and reducing the sediment and released maintenance cost. Sediment-laden water away from the reservoir through the upstream storage or the bypass tunnels and divert the sediment-laden water. Divert sediment-laden water away from the reservoir and divert the sediment-laden water away from the reservoir through the upstream storage or bypass tunnel. And sediment bypass require any significant infrastructure and investments, but offer any long-term benefit by preserving the reservoir storage capacity and reducing the sediment storage and related maintenance cost. Sediment management studies in the reservoir sediment bypass divert the sediment-laden water away from the reservoir through the upstream storage of the bypass tunnel. Sediment bypass systems requires an significant infrastructure investments but offer the long-term benefit by preserving the reservoir. Initial cost high but preserve the long-term store benefit of the reservoir storage by preserving the reservoir storage capacity and reducing the sediment-related maintenance cost. Sediment bypass often require significant infrastructure investments require the high cost investment significant high cost investment but provide the benefit on any long term benefit by preserving reservoir storage capacity and reducing the sediment laden and reducing the sediment related maintenance cost and reducing the sediment related maintenance cost and sediment bypass tunnel disadvantage due to the high discharge abrasion of the invert due to the grinding and impingement due to the high discharge and abrasion on the invert level of the bypass tunnels and due to the high grinding and impingement intake wireless element bypass and tailwater guiding structures and sediment line office floors are bypassed around the storage pools and sediment bypassed by the channel tunnel or the channels and symmetric and the turbulent flow around the rim of the vertical shafts and asymmetric and turbulent flow around the rim of the rim అనేది भित्रको भागलाई होला vertical shafts no clear and air core and along the shafts and sucking and blowing out of the air in the shafts and no clear air core along the shafts and asymmetric and turbulent flow around the rim of the vertical shaft asymmetric and the turbulent flow around the rim of the vertical shaft no clear air core around the shaft and sucking and blowing out of the air in the shafts and no clear air core along the shaft sucking and blowing out of the air in the shaft and risks of structural damage due to the sudden release of the pressure of the compressed air risks of this shaft no risks and no clear air core around the shaft sucking and blowing out of the air in the shafts and floating debris attractions and floating debris were diverted toward the bypass along the surface floor. Proposed to draw the excess and discharge from the near the river bed so that significant sediment load can be diverted along the excess discharge to the bypass systems. And the flow is pressurized culverts and then sloped upwards to the Obermeyer's Gate. Inclined shaft and through the pressurized culvert and the slope upward to the Vermeer gates and the additional benefit of the drawing discharge from the bottom is that an avoid the floating trash entering the bypass systems and extraction of the flow from the bottom and floating debris did not enter the bypass due to the lack of the surface spilling on. As the sides and the channels and it shoots with a vertical cut of 60 meters, the vast states into the lower on the velocity, the flow bypass the velocity at the end of the incline shaft was observed higher than 26 meters per second. And त्यो channel streams के अरे sediment pass through मा चाहिँ Reservoir sluicings are drawdown concepts and disadvantage discharge evaporation of the inward due to the grinding and impingement and our reservoir drawdown are the sluicings and concepts and reservoir and drawdown or sluicing concepts is to sustain the high maximized flow velocity and reduce the depth sustain the high masala maximize the sustain high flow velocity and reduce the depth through the reservoir to keep the sediment moving downstreams while minimizing the sediment depositions and sustain the high velocity throughout the sustain the high velocity and reduce the depth through the reservoir and sluicings are drawdown sluicings are drawdown and flushings and sluicings are drawdown sluicing or flushings and sluicing or drawdown reservoir drawdown and sustain the high flow velocity and reduce the depth through the reservoir to keep the sediment moving downstreams while minimizing the sediment depositions reduce the detention time to reduce the sedimentations and sustain high velocity and reduce the sustain high flow velocity and reduce depth through the reservoir. Sustain high flow velocity and reduce the depth through the reservoir to keep the sediment moving downstreams while minimizing the sediment depositions and sustain the high velocity and reduce the depth throughout the reservoir to keep the sediment moving downstream while minimizing the sediment depositions. Velocity high reduce depth and through the reservoir to scour the deposited sediments at the downstreams and reduce the detention times to reduce the sedimentations and reduce detention time to reduce sedimentations and high velocity through the reservoir to keep the sediment moving downstream while minimizing depositions and operational approach hold the reservoir at a low levels during the floods or the flows during the floods or flood seasons hold the reservoir at a low level hold reservoir at a low level during the flood or the flood seasons and require management of the high sediment concentration in diverted water. Operational approach old reservoir at a low level during the flood or the flood seasons require management of the high maintain sediment concentration in diverted water. Sustain the higher maximize the flow velocity and reduce the depth through the reservoir to keep the sediment moving downstream while minimizing the sediment depositions, reduce the detention time to reduce the sedimentations and sustain the sustain the high flow velocity and reduce the depth and sustain high flow velocity and reduce the depth through the reservoir to keep the sediment moving downstream. reduce the depth through the reservoir and you get to keep the sediment moving downstream and while and minimizing to keep the sediment moving downstream while minimizing the sediment deposition and reduce detention times and to reduce the sedimentation and operations approach old reservoir at a low level during the floods or the flood seasons and it require the management of the high sediment concentration in the diverted water old reservoir at a low level during the floods or flood seasons old reservoir at a low level hold the reservoir at the low level floods or the flow floods and at the low level flow and at the flood seasons and require the management of the sediment concentrations in diverted water. Operations approach and flow hold the reservoir at a low level flow and require the management of the sediment concentration in diverted require the management of the sediment concentration in the diverted water applicability. Efficiency and here will be vary considerably and depending on the reservoir configurations and hydrology. Efficiency depend upon the variability of the configurations and the reservoir configurations and the hydrology and efficiency will vary considerably depending on the reservoir configuration and hydrology based on long narrow reservoirs and require the large getting capacity gets flossings and are the sluicings and flossings and drawdown or sluicings and applicability efficiency will vary upon the river configurations and the reservoir efficiency will be vary considerably depending on the reservoir configurations and hydrology and the accuracy will vary depending upon the reservoir configurations and the hydrology based in long narrow reservoir and based in the long narrow reservoir and require the large gating capacity gets require the large capacity gates and suitable for the long narrow reservoir require for the large capacity gates and require for the large capacity gate and suitable for the large capacity gate based in the long narrow reservoir based in long narrow reservoir require the capacity gates and require the large capacity gates and require large capacity gate and you get it based in the long narrow rivers require large capacity gate efficiency will vary considerably depending on the reservoir configurations and hydrology efficiency will vary and you get considerably efficiency will vary and applicability efficiency will vary depending on the reservoir configuration hydrology and based in long narrow reservoir require the large capacity gates and operational approach old reservoir and at the normal water level and at a low level require management of the high sediment concentrations in diverted water. Sluicing Sonic operated at MDDL to FSL's level and velocity low, water level high, and conventional operations high, water level and low velocity, traffic efficiency and sediments. Maintain the water level and low velocity and efficient sediment handling conventional operating systems and as it gets open to minimize the water level and coarse sediment velocity high and depth flow depth decreases. Coarse sediments may continue to trap while the fine sediment is transported through the reservoir and fine sediment transported while the coarse sediments may settle on it. Sluicing operated at MDDL to sluicing case and get operated at MDDL to FSL's level and MDDL to the FSL's level. Conditions and CIR should be equals to or less than 0.7 for the more feasible station and long narrow reservoir one. And the required large getting capacity efficiency will be considerably depending upon the reservoir configurations and the hydrology and so conditions CIR and less than or equals to and get 0.7 is more feasible. So, when get used in the RR plant as sluicings are ADS and drawdown sluicings and sluicings used in the RR plant, and so no need to stop the plant operations, and as no need to stop the plant operations require additional settling machines to manage the sediment to reduce the sand concentrations to turbine. Spacings used in the RR plant has no need to stop the plant operation and require the additional settling basins. If Gonopolens require additional settling basins to manage the sediments to reduce sand concentrations to the turbine. And, as the reservoir is drawn down for the sluicing, the suspended sediment concentration in the river at the intake increased by factor of 10 to 1000. And sluicings, and as the reservoir is drawn down for the sluicings, and suspended sediment concentration in the river at the intake. Sluicing गऱ्यो भने चाहिँ अनि के the concentrations in the intake अनि के अरे sediments in the intake increased by factor of 1000. अनि sediment basins are used अनि के अरे the sediment basins used during the अनि drawdown period to reduce and concentrations अनि thus अनि the sediment basins are used during the drawdown period. The sediment basins are used during the drawdown period and to reduce the sand concentrations and delivered to the turbine. अनि sluicings मा अनि के अरे velocity कम हुन्छ अनि velocity बढी हुन्छ sluicings मा अनि के अरे देख्नुहुन्छ used for the CR less than or equals to 0.7 more physicals used in the RR plant has no need to stop the power plant operations. Require additional discharge and settling basins to manage the sediment to reduce the sand concentrations to turbine and drawdown crossings. And FS. Yes, and crossings and shut down of the power plant to flush the sediments from the bottom level of the outlet and erosion of the achieve the free flow condition at the outlet, achieve the free flow condition at the outlet, and sluicing and or the drawdown, maximize the flow velocity, reduce the depth to the reservoir to keep the sediment and to keep the sediment moving downstream while minimizing the sediment depositions. To keep the sediment moving downstream while minimizing the sediment depositions and reduce the detention time to reduce the sediment and reduce detention time to reduce sedimentations. Reduce detention time to reduce sedimentations and If a condition is achieved any because of the discharge rate and the stress and the deposits of the flushing release is limited by the low level outlet capacity. Flushing sediment and can achieve the sediment free flow. In the stricter condition of the outlet because the discharge and transfer sediment and flushing release is limited available for outlet capacity and because of discharge rate and transfer capacity of the flushing and release. Uh, Internal flushing achieves the free flow condition of the outlet achieves the free flow condition of the outlet because of the discharge rate and the transfer capacity of the flushing release. Because of the negative discharge and design because of the design discharge rate and the transfer capacity of the flow release is limited by the low level outlet capacity. And illusion is not only a possible to cross out of sediments that into the reservoir index should be located where the zone of the influence and crossings occur. Illusion that obstruction free flowing water. Discharge rate and transport capacity of the flushing release and it is limited by the low level outlet capacity and not possible to flush out the sediments that are in there. Discharge rate and transport capacity of the flushing release and because of the discharge rate and transport capacity of the flushing and because of discharge and transport capacity of the flushing and this is limited by the low level outlet capacity. Near is another deposit is in obstructions free flow water and achieve the free flow conditions at the outlet and because of the flushing discharge and near flushing rate because the near discharge rate and transport capacity of the flushing release is limited by low level outlet capacity it will not be able to flush out all the as is the free flow condition at the outlet because of the discharge rate and transport capacity of the flushing release is limited by the low level because the discharge and transport capacity of the flushing release and is limited by the low level outlet capacity and it is not it will be not an um, uh, as if the free flow condition at the outlet, as if the free flow condition out at and here because of the discharge rate and the transfer capacity of the flushing release rate. Because of discharge rate and flushing capacity is an discharge rate and the transfer capacity of the flushing release is limited by as if the free flow condition at the outlet because of the flushing discharge rate and because of the discharge rate and the flushing transfer capacity of the flushing release and because of the discharge rate and the negative transfer capacity of the net flushing release is limited by the low level because of the discharge rate and the transfer capacity of the low level flushing is limited by the because of the discharge rate and then transfer capacity of the because of the discharge rate and transfer capacity of the free flow condition at the outlet and discharge rate transfer capacity of the flushing release is limited by the low level outlet capacity and flush out all core sediment that enter the reservoir intake should be located where zone of the influence of the flushing will occur intake should be located where the zone of the flushing of the influence of the flushing should occur and thoroughly current deposits and fine sediment in flushing channels which can be released in the next flushing channels. Some more flood plains and keeps accumulating and these deposits not removed by the flushing channel. Because of discharge and transfer capability of the flushing release is limited by the transfer rate and discharge capacity of the low level outlet and of the flushing and because of the discharge rate and transfer capacity of the flushing and release and the discharge and transfer capacity of the flushing release is limited by the low level outlet capacity. It is not possible to flush out. It is not possible to flush out all the core sediment that enter the reservoir. It is not possible to flush out all the core sediment which enter the reservoir. And because of the discharge and transfer capacity of the flushing channel is limited. Because of discharge and then because of discharge and transfer capacity of the flushing channel is limited by the low level discharge and transfer capacity of the flushing channel is limited by the low level outlet capacity. It is not possible to flush out all the core sediments that enter the reservoir. It is not possible to flush out all the core sediments which enter the reservoir. Text should be located where one of the influence will occur during the flushing ceremony. Flushing ceremony. During flossing and get the plant operations and start not suitable for the RR and flossing discharge not required for the flossing size. It may require the large gate to handles. Also potentials to get failure of the structures. Create the artificial slot and which may release the and also create artificial slots which might release the 1,000 year of the already year of the return plot. So causing and destabilizing slope mass wastings and retrogressive erosions and mass stabilizing, destabilizing slopes are related to progressive erosions and discharge higher and flossing. So aims to low discharge, not the lowest through the flossings and discharge optimizations. And the delta will experience gradual advanced of the coarse bed material. To experience the gradual advanced of the coarse bed material. Sand will deposit at the top of the gravel and sand will deposit at the top of the gravel at the higher water level. Sand will deposit at the top of the gravel at the higher water level and will be scoured and transferred downstream during the flossings and scoured and down, causing delta to advance towards the dam. छोटे कर लेवाना रहने क्यारेक्टर कस्तो चुतिया आयो मुझी। Here's this dude. Raja Raja. Stupid bunny. Guy, what's the guy? If you don't have vision, is there? Kalau tidak nih nurun istilah. Ya nanti tanya. Ya versus tadi ya. Flossing any operated stuff so that video not videos of the error and I discharge not required the well and because of the discharge rate and the transport capacity and of the flossing release is limited by the low level outlet capacity and flossing discharge rate and the transport capacity of the discharge rate and transport capacity of the flossing and discharge and transport capacity of the flossing rate is limited by the low level outlet capacity. It is not possible to floss out all the force within that into the reservoir. Intake should be located with zone of influence of the flossing should occur and achieving free flow condition at the outlet and timing. And this is the most coincides with the timing and get a drawdown for solutions and the math and get a coincide with the people need not to coincide with people and outlet capacity may not be large and timing and most coincides with the people need must coincides with the peak load and you may not need not to be any need not to coincides with the peak load and the outlet capacity may not be large timing and intake on is may operate and may operate during the sluicing and cannot operate any uh, uh, as the water level is too low and sediment concentration is high and may operate during the sluicings and may operate during the sluicings and cannot operate only during the sluicings and the water level is too low and the suspended concentration is sediment concentration is too high and but not always the case outlet capacity and outlet capacity discharge on a larger flood with the maximum minimum backward discharge large floods with the minimum backwater and discharge and last floods with the minimum backwater and get discharge last flood the minimum backwater and discharge must be limited by the outlet capacity discharge and get may be limited by the outlet capacity sediment balance erosion pattern and no retroprogressive erosion and eh eh erosion causing destabilizing slope mass wastings and mass wastings and destabilizing of the slopes mass wastings and retroprogressive erosion and erosion pattern no retroprogressive erosion and this is location of gate and location of gate design and operate to achieve the desired hydraulic conditions and designed and operated to achieve the desired hydraulic profiles design and achieves to operated to achieve the design and operated and to achieve the desired hydraulic profiles design and operated to achieve the desired hydraulic profile design and operated to achieve the desired hydraulic profile location of the gate is designed and operated placed at a minimum practical elevations and minimum elevations to maximum hydraulic gradient and scar potentials and design and operated and to achieve any desired hydraulic profile and location of gate design and operate to achieve the desired hydraulic profile placed at an placed at a minimum elevations to maximize the hydraulic gradient and scar potentials and design and operated to achieve the desired hydraulic profile and design and operated to achieve the desired hydraulic profile and sweet have not affect environment during the drawdown and no retroprogressive erosion and the voice and discharge and flossing discharge and sediment balance and suitability for an CIR less than 0.7 all types and eh? Flossing says CR less than 0.7. I don't know, dude. And brothers. Sorry, sluicing energy and suitability and not affect the environment and any disasters of the environment that affect the disaster and not affect the environment the downstream impact during the flossings Timing must coincides with the peak flood and should not need not to be coincides with the peak flood, and the outlet capacity may not be large and need not to coincide with the peak, must coincide with the peak flood and drawdown sluicing, and get intake should be located more operated and it may operate during the sluicing, cannot operate during the sluicing as the water level is too low and sediment concentration is too high and outlet capacity discharge the large floods and then get a outlet capacity discharge the large floods and with the minimum backwater discharge large flood एउटा इन्टेक अनि एउटा सेडिमेन्ट ब्यालेन्स अनि इन्फ्लो इक्वल्स टु आउटफ्लो अनि टाइमिङ मस्ट कन्सिडर विथ द पिफ्लो टाइमिङ इन्टेक लोकेसन्स इन्टेक अपरेसन्स अनि त्यसपछि आउटलेट क्यापासिटी डिस्चार्ज लार्ज फ्लट्स विथ द मिनिमम ब्याकवाटर डिस्चार्ज मे बी लिमिटेड बाई द आउटलेट क्यापासिटी अनि डिस्चार्ज लार्ज फ्लट्स विथ द मिनिमम ब्याकवाटर अनि डिस्चार्ज मे बी limited by the outlet capacity, erosion pattern, regular progressive erosions or mass wasting. So then location of the gate design and operated and it should be designed and operated to handle the hydraulic profile and argos are placed at the minimum elevations to maximize the hydraulic gradient and the scarce potentials. Sediment balance discharge equals to inflow discharge greater than inflow and suitability CR less than zero for all types not affected by the environment during the drawdown and affected by the environment during the drawdown. And six. Pressure flossings and scours is and scour zones created by opening the bottom outlet while reservoir limits and operated at FSLs. Pressure flossing is operated at FSLs, very localized influence and able to clear area around the intake, not effective to flush the entire reservoir sediments. The water should be near water level should be operated at FSLs and get a very localized influence cause the very localized influence that is able to area and get a able to create clear the area very localized effect influence produce a very localized effect of the sediments that clear the sediments around the intake and not influence to flush the entire and carry reservoir sediments. The intake should be located where the zone of the influence should occur and pressure flushing scour zone. So slope of the scour cone will be steep in sandy sediments and the low in the finer sediments and angle of repose generally equals to 0.3 approximates and slope of the scour is steeps in the sandy sediments and low in the fine sediments and slope of the scars will steeps in the flow scars cones and get angle of repose भइहाल्यो अनि सेमी सर्कुलर इन्टके भइहाल्यो प्रेसर फ्लसिङ चाहिँ नि अब टरुडिटी अनि रिलिज अफ टरुडिटी यो सेडिमेन्ट राउटिङको होइन त राउटिङमा के थियो अनि के अरे सेडिमेन्ट बाइपास अनि र सेडिमेन्ट पास थ्रु सेडिमेन्ट बाइपासमा फ्लड च्यानल बाइपास अनि यो टनेल बाइपास सेडिमेन्ट अफ स्ट्रिम्स रिजर्भर र अन स्ट्रिम्स स्टोरेज अनि बाइपास अनि टनेलिङ भइहाल्यो अनि अर्को चाहिँ फ्लड बाइपास च्यानल चाहिँ यो फ्लड बाइपास च्यानल अपस्ट्रिम बाइपास स्टोरेज अनि अपस्ट्रिम के अरे सेडिमेन्ट पास थ्रुमा चाहिँ रिजर्भायर स्लुइस ड्रडाउन र रिजर्भायर स्लुइसिङ्स अनि फ्लसिङ्स ड्रडाउन र स्लुइसिङ्स एन्ड फ्लसिङ्स अनि के अरे अर्को चाहिँ फेरि पास थ्रुमा के फ्लसिङ स्लुइसिङ्स अनि प्रेसर फ्लसिङ्स नै भइहाल्यो मादर कस्तो याद नभए टरुडिटी बेस्ट रिलिज रह्यो turbidity based release and turbidity current one and get as the efficiency decreases over time and the reservoir fills with the sediments placed an outlet structures to release the tail turbidity current and placed an outlet structure to release turbidity current and decrease the efficiency and as the reservoir is filled with the sediments efficiency power production efficiency होला सायद अनि के अरे र हाइड्रोलिक इफिसियन्सीहरू सबै ड्यामेज इक्विपमेन्ट हुन्छ ड्यू टु द सेडिमेन्ट reservoir filled with the sediment over time. So place an outlet structures to release the turbidity current and release through the turbine or through a lower level outlets and release through the turbine or lower level outlet turbidity current over time and as the reservoir bottom filled with the sediment the condition of the movement of the turbidity current becomes less favorable as and a current flatten out and frictionals and boundary becomes larger and As a reservoir bottom fills with sediment, the condition of the movement of the turbidity current becomes less favorable. As the current flatten out and frictional boundary becomes larger, turbidity current bottom reservoir bottom fills with sediment. The condition of the movement of turbidity current becomes movement of the turbidity currents and becomes less favorable with gradual depositions due to the current flatten outs and frictional boundary becomes larger. Frictional boundary becomes larger. Current flatten outs and increase the depositions level over time. That is consolidations deposit from the turbidity current forming the higher density current, and that is consolidations of the deposits from the turbidity current. Consolidations deposits are movement of the current flatten outs and get a frictional boundary stress becomes larger and frictional boundary stress becomes larger, frictional boundary becomes larger and current flatten outs and increase in the deposition level. That is any consolidated deposits from the turbidity current flow forming the higher density current. Consolidated deposits forming the negative turbidity current and consolidated turbidity from deposits, consolidated deposits from turbidity current forming the higher density current. It is maintained by the reservoir flushings and maintained by the reservoir flushings and flushings on because and get operated FSL sub very localized nest that is able to clear not effective for the flushings the entire basins and reservoir and slopes of this capsule region. Already exist with transfer sediments to the dam and must already exist with transfer and place an outlet structure so that turbidity current is released instead of being trapped in sediments and air sedimenting and efficiency will decline over time as reservoir fills with sediments and turbidity current can be any operational process and released through the turbine or through the low level outlet and it does not require the reserve. Can be released to the reserve turbine or the low level outlet through the turbine or low level outlet does not require the reservoir drawdown. Any current flatten outs and frictional boundary and it becomes larger. Frictional boundary become larger, increase the depositions level over time. Consolidation deposits from turbidity current forming the higher density current and so it is maintained by the reservoir flushings. Turbidity current can be released through the turbine and or through the low level outlet does not require the reservoir flushings and plunge points and get marked by the accumulation of the floating debris and as the downstream flow meets the localized and get upstream sunny counter flowing and counter current created by the plunging flow and a surface counter meter and counter current turbidity current flows along the reservoir and muddy lake and of the turbid current which may not be settled into the consolidated deposits and consolidated deposits from the prior and turbid DT current released of the low level and turbidity current by the low level outlet and consolidation of the turbidity and deposits consolidated deposits due to the turbid current and release of the turbid current and by the low level outlet and the body lake of the turbid water and which has not settled into the body lake of the water and from the turbid current and which has not get converted into the consolidated deposits and delta deposits. Plunge points marked by accumulation of the floating debris and as the downstream flow meets the local upstream flow in flowing and a counter current created by the plunging flow and turbid flow along the reservoir and surface and counter current and turbid current sediment management techniques and multi-level intake and to withdraw the water from the turbid level. Multi-level intake to withdraw the water from the turbid level, turbid water flow, and multi-level intake structures to withdraw the water, turbid water and spills by tunnel and turbid water and consolidated settlements, clear water and multi-level and intake structures to multi-level intake structure to withdraw the turbid water and to avoid using the deep intake or outlet structure, use the siphon to aspirate the turbid water from the greater depth and bending turbidity and current through the turbine. It is possible to pass the sediment through the turbine with a little damage. However, the coarse data sediments cannot be allowed any. To avoid using the annihilated deep intake or the outlet works and use the siphons to aspirate and turbid water from the greater depth. And bending turbidity current through turbine and it is possible to pass fine sediments through turbine with little damage. However, coarse delta systems cannot be allowed any. Aspirations of the turbidity current over the spillway using the ungated curtain outlet any. Aspirations of turbidity current over the spillway any. Aspirations of the turbidity current over the spillway using the ungated turbine and cotton wall outlet. Aspirations of the turbidity current over the spillway. Aspiration of the turbidity current over the spillway and aspirations of turbidity current over the spillway using the ungated cotton wall outlet and turbidity water cotton wall intake and turbidity current माथि बाट गयो flood discharge with the turbidity current अनि delta deposits and turbidity current and venting and submerged and terrace and this was turbid current and sediments deposits and turbid current while maintaining turbidity channels and current channels by reservoir flushings and turbidity current bending and will typically become more difficult over time as the reservoir bottom fills with the sediments. The condition for the movement of the turbid current becomes and as the reservoir bottom fills with sediment, the condition for the movement of turbid becomes very less favorable. So current flatten outs and frictional boundary becomes larger and flattens and larger increase the depositional and increase the depositional level over time, that is consolidated deposits with form the turbidity current forming a higher density current, increase opportunity to sediments by depositions over time. Turbid channels can be maintained by flushings and increase opportunity to entrain the clear water across the top boundary, increase opportunity to entrain the clear water, increase opportunity to lose sediments by deposits on the bottom, increase and opportunity to lose lose sediments by depositing on the bottom. Anticipate any future sediment pattern and mitigation strategy and change over time and reserve fuel with sediments, cotton falls and release turbidity current through the flood outlet and through the turbine and Sediment removal in the reservoir dredging and it involves mechanically excavated sediments from the reservoir by using the specialized equipment and sediment removal in the reservoir removal अथवा redistribute the sediment deposits and mechanical removal and manual modifying the operating rule and hydraulic scouring and mechanical removal modify the operating rule hydraulic scouring and mechanical removal and modify the operating rule hydraulic scouring and mechanical removal modify the operating rule hydraulic scouring. Hydraulic scouring, pressure flushing or empty flushings and mechanical removal, dry excavations, dredging, and hydraulic dredging and hydraulic suctions dredging, airlift dredge, mechanical lifts, hydraulic dredging and hydrosuctions dredging, airlift dredge, mechanical lift, air agitations dredge and dredging involves mechanically excavating sediments from the reservoir bed using the specialized equipment and involves mechanically excavating any sediments from the reservoir bed using specialized equipment, rarely economically and feasible on the large scales due to the high cost and logistic challenges. And the main challenge finding suitable deposits, disposals and finding suitable disposal sites for large quantity of the dredged sediment, disrupt any aquatic habitat, disrupt sediment layers, release suspended sediments into the water column. Mechanical excavating sediments from the Nigeri Reservoir using the specialized equipment and involves mechanically excavating sediments and mechanical excavations and yeah, mechanical excavations are through the dry dredging अथवा dry excavations dredging and dredging involves mechanically excavating and mechanical and was mechanically excavating the sediments from the reservoir bed. Mechanically excavating the sediment from the reservoir bed using the specialized equipment excavating the sediment from the reservoir bed using the specialized equipment and mechanically excavating sediments and mechanically excavating sediments from the reservoir bed using the specialized equipment. Mechanically excavated sediments from the reservoir bed using the specialized equipment rarely economical feasible on the large scales due to the high cost and logistic challenges. Economically feasible on large scales due to the high cost and logistic challenge. Main challenge and find the suitable disposal sites for the large quantities of dredged sediments. Find suitable disposal sites for the large quantities of the trade sediments. Find the suitable disposal sites. Main challenge finding the suitable sites, disposal sites for the large quantity of the dredging sediments. Disrupt aquatic habitat, disrupts sediment layers and release and suspended sediments into the water column. Disrupt aquatic habitat, disrupt the sediment layers. This main challenges and disposal sites and suitable place for the disposal sites of the large quantity of the trade sediments. Disrupt the aquatic habitat, disrupt the sediment layer, release the suspended sediments into the water column dredging and mechanically in excavated sediments from the reservoir using the mechanical excavated sediments from the reservoir bed using the specialized equipment and rarely economically feasible on the large scales due to the high cost and logistic challenges and uh, deep digging dredges and excavate up to the 50 meter of the hydrosuction dredges and uh, reduce the energy cost by eliminating the pump and use the different of the differences of the head between the water level and discharge points and as any pumped the difference in the reduced energy cost by eliminating pump using the reduced energy cost by eliminating or use the difference of the reduced water level and discharge point as any pump and for the dredging and head greater runs and length से कम versions of that energy gradients boards and in discharge the sediment into the river below the dam. Is often talked about really is a large scale from finding disposal sites and empty flossings and empty the reservoir and allowing river to scour the sediments and hey, deep digging dredges and get excavate up to the 50 meter depth plain suctions dredges in the water jets and plain suction dredges with water jet and deep digging dredges excavate up to the 50 meter and depth and Sauriman drag line and hydraulic cautered hydraulic and cautered dredges and hydrosuction states reduce the energy cost by eliminating the pump, reduce the cost by eliminating energy cost by eliminating the pump, and use the difference in the water level and discharge pipe always underwater and get a total availability. And reduce the energy cost by eliminating the pump and reduce the any cost by eliminating the pump. Use the difference in the water level between the and the discharge points and get a difference in the water level and the discharge points as the and get a pump and use the difference in the head between the water level and discharge points. So it is often referred to as a pump for dredging and normally must discharge into the river below the dam and distance from the dam limited to 2 kilometers due to the friction losses and the limitation in the available energy from the difference. Reducing the difference in the water and normally discharge to the river below the dam and Suitable for the discharge into the river below the dam. Suitable for the discharge into the river below the dam, and any distance from the Anigiri dam of 2 kilometer, and due to the friction losses and limitation in the available energy from the difference in Iran. Pumps are not required as available and usually get act as a pumps and jetting required to lose the consolidated sediments and hydrosuccess rating and then outlet Anigiri over the dam crest outlet through the Anigiri spillway crests water through the lower pipe get permanently installed casings pipe through the dam. Locations on outlet on area of the dam crests and Mathirang signs and outlet through the spillway gate crests dam go crests man intake gate one as spillway gate Matthew 2 number you and 1 number dam crest one as argo water through the lower gate and argo permanently install casings pipe through the dam and suitable for the discharge of the river below the dam and distance of the dam from the about 1 2 kilometer due to the friction loss and limitation in the available energy from the difference in head and reduce the energy cost by eliminating the pump and use the difference in the head between the water level and discharging points and get as the pump and pump are not required as the available ideally get act as a pump and the jetting required to lose the consolidated sediments and pumps either but jetting they will jetting required to lose the consolidated sediments and locations and get location at the Nigere crest of the dam and location of the Nigere outlet of the crest of the dam outlet over the dam crest Nigere outlet through the spillway gate outlet over the dam crest outlet through the spillway gates water through the lower gates permanently installed casings pipe through the dam and factors and favoring dredging and well developed technology factors favoring dredging and well developed technology control sediment removal scalability and water efficiency and well developed technology control sediment removal and well developed technology control and sediment removal scalability water efficiency require small and deep dredging dredges right suction dredges त्यति मात्र रहेछ अनि disposal and flexibility clean transport and energy utilizations last resort energy and no reservoir operations change water efficiency and require the small water for the discharge dredging and scalability and control sediment removal well developed technology a factor affecting governing dredging and well developed technology control sediment removal well developed technology control sediment removal well developed technology control sediment removal scalability well developed technology and control sediment removal well developed technology sediment control remove control sediment removal scalability and well-developed technology control sediment removal and well-developed technical factor governing dredging well-developed technology control sediment removal scalability and well-developed technology control sediment removal scalability and water efficiency no reservoir operations and disposals flexibility clean transportations and this was energy utilizations and driver can use the cheap supply energy and last resort energy can be used when the other method work not done regarding well developed technology and you get a control sediment removal can exactly control the amount of the sediment removal control sediment removal well developed technology control sediment removal and scalability and relatively for the small amount of the work and is for the very small amount of the work well developed technology and control of the sediment removal scalability water efficiency requires small water for the dredging water efficiency requires small and water for the dredging no reservoir operations change and No reservoir operation change and you get a disposal flexibility, clean transportation, so disposal flexibility, clean transportation, energy utilization, last resort of the energy. Factor limiting dredging and high cost energy intensive technology which leads to the high operational cost energy intensive dredging तर हाइड्रोलिक सक्सन त पम्प लाग्दैन तर त्यो के अरे जेटिङको लागि चाहिँ लाग्छ अनि लङ टर्म सस्टेनेबिलिटी अनि फ्याक्टर लिमिटिङ लङ टर्म सस्टेनेबिलिटी with the disposal sites are limited and as the disposal sites are limited and strictly speaking it is only sustainable if the sediment is discharged back into the river and yes and get environmental impact and high variable site and specific and site specific high cost energy intensive long term suitability sustainability and environmental impact well developed technology control the sediment removal and scalability water efficiency and require small water for dredging no operations and no reservoir operations change any disposal flexibility clean transport and energy utilization last resort of energy. uh, Emptying and flushing and get emptying and the with the mechanical removal and modifying the operating rule hydraulic scars pressure flushing and empty flushings and reservoir and pressure flushings and hydraulic scars and emptying the reservoir and allowing the river to flush out the sediments, emptying the reservoir and allowing the river to flush out the sediment, emptying the reservoir and allowing the river to flush out the sediment, environmental impact, downstream release of the muddy water and proper management is crucial to mitigate larger downstream environmental impact. Remove the limited volume of the sediment, impractical for the larger sediments, sediments removal operations, impractical for the larger sediments, emptying the reservoir and allowing the water to flush out, emptying reservoir and allowing the water to flush out through the sediment and flushing and flushing and emptying the reservoir and allowing the water to flush out the sediments. Environmental downstream release of the muddy water and improper management crucial to mitigate that large downstream environmental impact. Remove the limited volume of the sediment. Remove the limited volume of the sediment. Impractical for the large scale sediments removal operations. And 149 meter high central core rock fill dam and install capacity 92 megawatt commissions in 1982. Surface area is about 2.2 kilometer square at a maximum operating level. Surface area is about 2.2 kilometer square at maximum operating level. Original live storage capacity was 70.3 mega million meter cube and the storage 12 million total capacity 1.6 kilometer full solar level and memorial and again surface area 2.2. The reservoir lost 1.5% total capacity and 1920 and 1990 and traditional area and also the info volume for the 24 hours and get it from 12 on 19 July to 16 and get on 20 July and calculated 50 million million with a peak discharge of about 1040 million cubic second and this record corresponds to the 1000 years and return period according to the available data and some important structure of the Kulikhani stations were seriously damaged by the flood and power generations of both Kulikhani and रिजर्भ भ्यालु डिपोजिसन घट्दै जानु भनौँ सेडिमेन्ट डिपोजिसन होला सायद immediate restorations for the operations of the power plant completed in 5 months and restorations for the operation of the power plant permanent restorations immediate restorations and completed in 5 months engineering study carried out permanent restoration of both power stations and engineering study and the detailed design of the permanent restoration of the Kulikhani Power Station Master Plan study for the sediment control of Kulikhani Reservoir and to execute construction of the counter and measures based upon the recommendation of the studies urgent counter measures to sediment issues of the reservoir permanent restorations of the Kulikhani to Anigiri head work and permanent restoration of Kulikhani to head work and construction of the project inspections road installation of the telemetric systems and warning systems and procurement of the constructing equipments and or then countermeasures to sediment issues of the reservoir, or then countermeasures to sediment issue of the reservoir, sloping intake check dam, and urgent and get a countermeasures to sediment issue reservoir and counter use the sloping intake and get a check dams and use the urgent counter and measures countermeasures to and get a sediment issues of the reservoir, sloping intake and check dam, sloping intake check dam and or permanent restoration of the Kulikhani headwork and embedded mandu headphone आणि headphone embedded intake आणि na intake राखे outlet on LAN आणि गेले outlet on LAN rapti pumped intake आणि construction of the project inspections road आणि construction project inspections road installation of the telemetric systems and warning systems installation telemetric systems or warning systems आणि outlet on LAN rapti pumped intake आणि गेले headphone आणि embedded intake headphone आणि intake ra आणि गेले outlet on LAN rapti tunnel sloping intake आणि code check dams आणि installation telemetric and sensor warning systems procurement of constructing equipment and monitoring of the sediment deposited in the reservoir and get sediment management strategy आणि sediment monitoring सर्वात आणि monitoring importance आणि a key component of the sediment monitoring and important sediment monitoring and this was indispensable for the effective sediment management in the reservoir due to the role in understanding sediment transport process predicting the sediment transport pattern and Gente, ಇವನೇ भी हो दिन तफासिले हुए देखा एक ख्वाब तो इसलिए हुए Monitoring and study, monitoring and strategy. Monitoring and the importance of monitoring and is indispensable. Sediment monitoring encompasses sanitary monitoring indispensables for effective sediment management, reservoir understanding, sediment transfer process, predicting sediment pattern, assessing the impact of sediment on the reservoir and ecosystems. And understand sediment transport process, predict sedimentation's pattern, and assess the impact of sediment on. Roles understand the sediment transport process, understand sediment transport process, predict the sedimentation pattern, understand the sediment transport process, understand sediment transport process, and predict the sedimentation pattern, access the impact of sediment on the reservoir, operation, and ecosystems, access the predictions of the impact of the sedimentations on the reservoir, access the predictions of the sedimentations on the reservoir, and operations and ecosystems, so the access the impact of determine the impact of the sedimentations in the reservoir, operation, and ecosystems, so the continuity and maintaining the continuity and maintain the continuity and equity between the sediment and the discharge within the reservoir. Problem solves and tracking several parameters which include maintaining the continuity of sediment and discharge within the reservoir involves tracking several parameters and discharge and staff level goes for the recording and measurements of the determining the inflow and the outflow of the maintaining the continuity between the sediment and the maintain the continuity in between the sediment and the discharge within the maintain the continuity between the sediment and the discharge within the reservoir involves tracking the several parameters maintaining the continuity and continuity between the sediment and the discharge and within the reservoir involves tracking of the several parameters and which include the discharge and discharge के भन्छ वाटर लेभल अनि सेडिमेन्ट लोड थुक्केपछि सेडिमेन्ट लोडबाट डिस्चार्ज सेडिमेन्ट लोड अनि याड के विन अनि के अरे सेडिमेन्ट कन्टिन्युटी भनेको चाहिँ अनि भिटी प्लस वान इक्वल्स टु भिटी प्लस क्यु इन माइनस क्यु आउट माइनस इटी माइनस एलटी एलटी भने सिपेज भइहाल्यो एलटी कहाँबाट दिने तल दिनु पर्ला सरी अनि भी स्पेसिङ चाहिँ टेन टी प्लस वान is equals to vs at time t plus qs in अनि as qs out अनि यो भनेको डिस्चार्ज यो भनेको चाहिँ सेडिमेन्टको अनुसार चाहिँ सेडिमेन्टमा चाहिँ भिएस भिटी प्लस वान भिटी प्लस अनि क्युइन माइनस क्युआर अनि डिस्चार्ज अनुसार चाहिँ भिटी प्लस वान भिटी प्लस क्युइन माइनस क्युआर माइनस इटी माइनस एलटी अनि sediment maintaining the continuity between the sediment and discharge within the reservoir involves tracking of the several parameters discharge sediment load and get discharge and crucial for understanding the water balance within the reservoir and determining the accounting for the losses and crucial for determining the water balance within the reservoir determining the crucial for determining the water understanding the water balance within the reservoir and additionally accounting for the losses of the evaporations recipes and staff gauge use the staff gauge discharge normally use the staff gauge for recording the water level and water level sensors for recording the water level with the telemetry facility. And use the staff gauge for recording the water level. Use the staff gauge for recording the water level. And water level sensors for recording the water levels. Use the water level sensors for recording the water levels with the telemetry facility. And use the water level sensors for recording the water level, and use the staff gauge for recording the water levels. Use the staff gauge for recording the water level and the water level sensors for recording the water levels with the telemetry facility. Sediment load on tracking the sediment and suspended and the bed load and get fluxes and to quantify the sediment transfer dynamic, and analyzing of the sediment and suspended and the bed load fluxes, tracking on both and suspended and the bed load flux to quantify the sediment transfer dynamics within the reservoir, include measuring the sediment inputs from the inflow as well as sediment through losses through the outflows and reservoir bathymetry survey. Bathymetry survey to Somali and measurements integral part of the life cycle and management process. And paradigm wise, what gets monitored gets improved temporal variation, discharge sediment load resulting from the dynamic in the catchments conformations of the sediment yield. And integral part of the component of the any monitoring is an integral part of the component of the life cycle design paradigm. And what gets monitored temporal variation of the sediment load resulting from dynamic in the temporal variation, the sediment and the discharge loads from the discharge and the sediments from temporal variations resulting from the dynamics in the catchment conformations of the sediment yield. And evaluate the discharge and sediment balance, calibrate to the model. And evaluate the discharge and the sediment balance, evaluate of the discharge and sediment balance calibrations of the model, effectiveness of the sediment management methods for continuous adjustment and optimizations, effectiveness of the sediment measurements management methods for continuous adjustments and optimizations, downstream impact of the sediment management, downstream impact of sediment management. And reservoir involve mapping the reservoir bed to understand the change in volume and sediment depositions pattern reservoir bathymetry over time. An echo sounder with the DGPS is used conducted by maneuvering the boat around the track line in cross sections. And mm, involve the mapping reservoir bed to understand the change in the involve mapping of the reservoir bed to understand change in bed volume and sediment depositions pattern and reservoir bathymetry over time. And change in the need to change in the volume and change in the sediment and depositions pattern, change to determine the understand change in volume, change in the sediment depositions pattern and reservoir bathymetry over time. Echo sounder with the DGPS is used, which is construct conducted by maneuvering the boat around the track line in the cross sections. And because on the DGPS is used, which is conducted by maneuvering the boat around the track line in the cross section time and directions. And because sounder with the DGPS and reservoir mathematics are involved mapping of the reservoir bed to understand change in volume depositions pattern or sediment depositions pattern in reservoir bathymetry over time. Because sounder with the DGPS is used, which is conducted by because sounder with the DGPS is conducted by maneuvering the boat along the track line in the cross sections directions. And because sounder with the DGPS conducted by maneuvering the boat along the track line in the cross section directions. Eco sounder types and single beam or double beam. Single beam measure the depth of the narrow area, easy to operate and cheaper, and double beam measure larger area, more sufficient, but more efficient. And double single beam measures of the depth narrow and depth of the measure the depth of the narrow area, easy to operate and cheaper, and easy to operate and cheaper measure the depth of the narrow area, and double beam and measure the larger area, more efficient but difficult to operate and costly. And measure the larger area, measure the depth of the narrow area, easy to operate and cheaper. Single beam or double beam involve the mapping of the reservoir bed and need to understand the change in volume and change in the reservoir, the sediment depositions pattern and reservoir bathymetry over time. Eco sounder with the DGPS. Eco sounder with the DGPS is used, which is carried by maneuvering the boat along the track line and in with cross sections directions and maneuvering the boat along the track line cross directions and eco sounder with DGPS on GPS on draft on transducers and depth below the transducers and reverberate draft value and transducers and depth below the transducers GPS rover and closer track line recommended during the single beam measurement to minimize the cross and to minimize the error from the interpolations and closer track line recommended during the single beam and closer track line is recommended during the single beam and measurement closer track line and recommended for the single beam measurement to minimize the error from the interpolations closer measurements and closer track line recommended during the single beam measurement and for closer track line recommended during the single beam measurement to minimize the error from the interpolations and a closer track line recommended from the single beam measurement and to minimize the error from the interpolations and importance and you track the volume depletions and the sediment depositions over time. Track the volume depletion sediment depositions over time. Revising the elevations capacity curves to accurately estimate the reservoir volume under changing sediment conditions and extrapolating any future reservoir volume. Predicting the sediment problem and evaluating the effectiveness of the sediment management practice and calibrations of the sediment transport model. And control updating the reservoir volume of the reservoir. Mathematic data. The best represents the street surface of the reservoir bed on a also to depict the depositions pattern of the sediment through the contour method. And the GPS record XYZ coordinates of the transducers mounting on a point. Ecosounder measures the depth from the transducers points mounting point. These records are data recorded and processed to generate the contour map error. Importance on tracking the volume depletions and the sediment depositions yield over time, tracking the ungated volume depletions and sediment yield over time, and revising the elevations capacity curve to accurately estimate the reservoir, revising the capacity elevations capacity curves to accurately estimate the reservoir volume and to accurately estimate the reservoir volume under changing sediment conditions and extrapolating the future reservoir volume, extrapolating the future reservoir volume, track the volume of the depletions and sediment depositions over time, sediment yield over time, revising the elevations and capacity curve and revising the elevations capacity curve to accurately and estimate the reservoir volume under changing sediment condition, extrapolating the future reservoir volume, extrapolating future reservoir volume, predict the sediment problems and evaluating the effectiveness of sediment management practice, predict the sediment problems and evaluating the effectiveness of sediment management, predict the reservoir sediment problems, predict the sediment problem, evaluating the effectiveness of sediment management practice, calibration of the sediment transport model and predict the sediment problem, evaluate the effectiveness of sediment management practice, predict the sediment problems, evaluate the effectiveness of sediment management practice, calibrations of sediment transport model and calibration sediment transport model, predict the sediment problems, predict sediment problem and evaluate the effectiveness of sediment management practice, predict the sediment model and importance and track the volume of sediment depletions and the volume depletions and sediment depositions over time, revise the elevations and capacity curves to accurately estimate the reservoir volume under changing reservoir elevations and capacity curves and revising elevations capacity curve to accurately estimate the reservoir volume under the changing sediment conditions and extrapolating the future reservoir volume, extrapolate the future reservoir volume, extrapolating the future reservoir volume, predict the sediment problem and evaluating effectiveness of sediment management practice, predicting the sediment problem and evaluating the effectiveness and predicting the sediment problems and evaluating the sediment management practice and calibrations of sediment transport model and predicting the sediment problems and evaluating the effectiveness of sediment management practice, calibrations of sediment transport model and closer track line is recommended during the single beam measurements. Closer track line is recommended during single beam measurements to minimize the error from the interpolations and bathymetry data processed and interpolate of the 3D surface of the reservoir. bathymetry data processed and interpolate data processed and interpolate the 3D surface of the reservoir bed and interpolate the 3D surface of the reservoir bed, which helps to depict the depositions pattern, determine the depositions pattern of sediment throughout the contour method, and helps to depict the negative depositions pattern of the sediment, helps to depict the depositions pattern of the sediment throughout the reservoir and through the contour method. DCPS record XYZ coordinates and transducers mounting points. DCPS record the XYZ coordinates and transducers and of the transducer mounting points. DCPS record the XYZ coordinates of the transducers mounting point. DCPS record the XYZ coordinates with the transducers mounting point, and ecosounder measures depth from the transducers. Ecosounder measures the DCPS record XYZ coordinates and get a DCPS, and ecosounder with the DCPS, where the ecosounder with the DCPS. Ecosounder measures the depth from the transducers mounting point, and DCPS record the XYZ, and DCPS record the XYZ directions, and ecosounder measures the depth from the transducer mounting point. These data are recorded and processed to generate the contour map, and bathymetry data is processed to data is processed and interpolated for the 3D surface of the reservoir where the data bathymetry data processed and interpolated for the bathymetry data is processed and interpolated for the 3D surface of the reservoir bed, which helps to depict the depositions pattern of the sediment through the contour method, which helps to depict the sediment depositions pattern through the contour method. These data are recorded and get a process to generate the contour map error, and get a data recorded and process to generate data are recorded and process to generate the contour map error and corrections during the post processing is necessary to ensure the accuracy of the contour line, and eliminating the error corrections during the post processing is, and these data are recorded and then you get a prepared process to generate the contour map, and DCPS ecosounder. DCPS record the XYZ coordinates of transducers mounting point, and ecosounder measures the depth from the transducers mounting point, and cautions datum and change in water level and a reading leading error in data processing. Datum change in water level error and error during the post processing necessary to ensure the accuracy of the contour line and eliminating the contour map, and periodic bathymetry survey and is required to estimate change in the reservoir volume over time, and mm, sediment bulk density and sediment bulk density measurement, and it's a bulk density measurements माझा आणि grain size distribution density weight of the sediment volume of sediments and sediment yield is measured in mass rate and ton per year sediment yield, and bathymetry survey measure the volume of the sediment deposits, where bulk density measure the required measurements required to convert the sediment yield in reservoir volume, measurements and require bulk density measurements required to convert the sediment yield in reservoir, and to convert the sediment yield in reservoir volume loss and bulk density depend upon the depend on particle size distributions and degree of compaction, and degree of compaction depend upon the degree of compaction depend upon the process of periodic dewatering, degree of consolidation, threshold and overburden process, and monitoring and sediment core in the reservoir are used to gather the information required, and There is a sediment core in the Nigeri reservoir or sediment core in the reservoir are used to gather the information. Sediment core in the reservoir is used to gather the information for the bulk density calculation. And sediment composition depth of the deposition changes along the reservoir. Samples represent such variability has to be collected. Sediment composition depth of the deposition changes and sediment composition depth of the deposition changes along the reservoir. Samples represent the such variability has to be collected. Full penetrating core and more accurately and full penetrating cores are more accurate but costly and shallow and core sediment compositions, depth of the deposition changes, and sediment compositions and the depth of the depositions. Key depositions and sediment depositions, sediment compositions, and the depth along the depositions and changes along the reservoir sample representing such variability has to be collected and sediment core in the reservoir used to gather the information bulk density can and full penetrating core and monitoring in reservoir and shallow cores less accurate and but cheaper and require the empirical adjustments for the compactions less accurate but cheaper and modeling deposits and contains trapping cells, elements, numerical models are powerful tools and sediment yield often expressed in terms of the mass and provide information about the amount of sediment entering and provide information about the sediment entering or leaving the reservoir. Cast provide the information on the sediment entering and leaving the reservoir and try to convert the sediment yield in the reservoir as it provides the information on the amount of sediment entering and leaving the reservoir. Mathematics are measure the survey and get measure the volume of sediment deposited within the reservoir bulk density measure essentials convert them. Essential converting sediment yield into the and the bulk density are essentials for measuring the bulk density measurements are essentials for converting the essentials for converting sediment yield and essentials for converting the sediment yield and essentials for converting the sediment yield into the estimates of the reservoir volume loss bulk density of the sediment depend upon the factor such as particle size distribution sediment compactions and hydrophobic bulk density is affected by any bulk density is influenced by the particle size distribution segment and the degree of the consolidation so and compaction. The degree of compaction will depend upon the period of dewatering and consolidation effect of the sulfate and overburden pressure in reservoir. Delta deposit may exhibit varying bulk density with the coarser sediments irrigated by drawdown while fine sediments deeper parts remain submerged and sampling and the core section sampling and cores are collected from the various locations within the reservoir to gather the information required for the bulk density calculation. Sediment cores are reservoir are used for gathering the information for bulk density calculations and sedimentary compositions and depth of the depositions and vary along the reservoir, necessitating the selection of sampling representing this variability. And the full penetrating and core and provide the accurate and shallow core, less accurate, cheaper and full penetrating or shallow core and methodology. Sediment core are typically collected using the specialized equipment and using equipment and such as sediment core or the graph samplers and use the equipment sediment core or graph samplers and the cores are extracted from the different depth and locations to capture the cores are used to capture the sediment cores are extracted from the different depth and the locations to capture the spatial variability of the sediment characteristic used to calculate used to extract from the cores are used to extract the samples from the different depth and the locations to capture the spatial variety capture the to capture the spatial variability of sediment characteristics space variable and capture the different then extracted from the different and the sample the core is used to extract the samples from the different depth and the location to capture the spatial variability of the sediment character and laboratory analysis and graph samplers and sediment involves the drying samples to determine the or laboratory analysis and used to core and involves drying samples to determine dry weight corrections may be applied to ensure the accounting and compactions and the similarly bulk density measurement plays a vital role in understanding sediment dynamic estimating the sediment yield and vital role in understanding sediment dynamics and estimating the sediment yield and accessing the reservoir volume loss and proper sampling techniques and then modeling modeling sadhana. Get sediment diameter particle size distribution sediment loader sediment yield sediment and diameter particle size distribution sediment concentration sediment diameter particle size distribution sediment loader sediment yield पांचरा आणि एक मैदान Stream.